Thank you very much for inviting me here. So I'll present myself. My name is Inna Sharf, and I'm a professor in the Department of Mechanical Engineering at McGill University. And I'm co-directing the Aerospace Mechatronics Lab at McGill. So as you can see from my title, today I'm going to tell you a little bit about the work that we're doing with aerial vehicles, unmanned aerial vehicles, also known as drones. We tend to call them UAVs. And I'll talk a little bit about, I'll tell you a little bit about some of the vehicles we have in my lab. And I'll say a few words about the research that we're doing with these vehicles, and also mention some of the plans that we have for the near future. So what we tend to do for the vehicles that we have in my lab is we typically purchase commercial vehicles, and there are actually a few companies in Canada that manufacture drones, UAVs. So there are two vehicles that are showing in the slide from Dragonfly Corporation in Saskatoon. One thing that I'll point out is that we tend to work with vehicles that are called rotary vehicles. So they have, and they have multiple rotors, multiple propellers on them, and we call them multi-rotor vehicles. So there are two of these in this picture. I'll mention a couple of others. So on my left is Q-Ball, which is also a vehicle manufactured by a Canadian company, Quanzer, in Ontario. And as you can see, it has a protective cage around it to protect both the vehicle and the people that are working with it. Another vehicle that we have in my lab is Pelican from a German company, Aztec. And our latest acquisition is the vehicle at the bottom, which is called SÉRI, from a startup company, Pleiades, which is still trying to get themselves up and flying. I also have some vehicles that I can't fit in my laboratory, and those fall into the category of lighter than air vehicles, or what people mostly know as blimps. And over the last few years, I've been involved in a really fun project, which involves a very large cubic blimp. It's called Trifon. And this work was done as part of the Aerostabile collaborative project with UQAM and Laval. And just to give you an idea for the size of this blimp, so to make it even more special, it actually has a square shape. And the shape of this blimp is maintained by a truss structure that surrounds it. And the blimp is about 2 meters on the side. And the reason it's not in my lab is because we can actually barely fit it in my lab, let alone fly it and do some experiments with it. This project is incredibly fascinating because the project is driven by a person who is an artist and an architect. And they are interested in making use of these large blimps in artistic performances, putting them in very unique environments. So here I have a picture of this blimp, which we've flown in a cave, in a very large cave in France. And this is an incredible sort of opportunity, an incredible application of something like this, where you can take a blimp in an area where you really can't get to very easily and fly a blimp in such an environment. Here's another picture of the blimp used in the performance, where you can see there's a projection of lightning onto the side of the blimp, and there's a dancer under it. The reason we got involved in this project was actually to develop controllers for the blimp, and to develop controllers that would allow several blimps to dock to each other. So here in this picture, which was also an artistic performance at SÉRI Montréal, so you see two blimps there. So we worked on developing docking controllers to allow two blimps to dock to each other, so you can actually build a structure in air that would float. Okay, now what are some of the things that we're actually interested in doing research on? As some of you know, I'm sure drones is something that's practically becoming a utility You can buy a drone, and many of you here probably can easily afford one, and you can fly it, go fly it in a space and have fun with it. It's a lot of fun. But what if you want to actually put drones to real use, to make them do something useful for humanity, for people? So our objective is to make drones, small UAVs in particular, more autonomous. And that's a very loaded word. It can mean a lot of things. But some of the things that we're interested in working on are, we want to make the vehicles more autonomous for landing, and that's actually a very difficult task, often even for a pilot to do, to land the vehicle safely, especially if it's outdoors and it's windy. And generally flying in unknown environments, so you can send the vehicle somewhere where you can't see it, and it can fly around autonomously and possibly land itself autonomously, for example, on a roof, on a rooftop. We want to be able to autonomously navigate from one place to another without colliding with anything, with any obstacles that might be along the way. In an urban environment, of course, that's buildings, poles, trees. One of the projects that's actually happening currently in the lab is we want to be able to have a vehicle recover from an accidental collision. So if it does collide with a wall or with a pole, rather than crashing to the ground and basically ending the mission, we want to be able to recover the vehicle from this collision, which is something that birds are able to do sometimes if they don't hurt themselves. And as I mentioned, in the context of the blimp project, we want to control multiple blimps for artistic performances so that they can dock autonomously, interact with artists, respond autonomously to artists' gestures or voice commands. So to do all of these things, we sort of we have to tackle a range of problems. One of the things that we do a lot of in the lab is we do a lot of modeling and simulation. We develop modeling and simulation tools, so create virtual environments in which we can virtually experiment with our vehicles, like the snapshot shown here. We do a lot of system integration, and so, as I mentioned, the vehicles that we have in the lab are vehicles that we usually buy commercially. They're commercially available, but if you want to make them more autonomous, that means that you might need to put more sensors on them. You might need to replace the brain of the vehicle, the main processor board. You might need to redesign some of the structural components. So we do a lot of system integration, hardware integration, software integration, and these tools are constantly developing and actually getting better. Another thing that we've tackled is tracking, localization, and mapping. So this is sort of a loaded problem, and if you want your vehicle to operate autonomously in an unknown environment, it has to be able to see what's around it, and it has to figure out where it is relative to the things in that environment. So that's localizing itself. It has to map the environment in order to be able to localize itself to it. And ultimately, the vehicle has to know what its state is. So we developed a multi-camera vision-based solution to do this with multiple cameras on the vehicle. Guidance and control, I already mentioned. How do you navigate from one place to another autonomously? This is a guidance and control simulation for the two blimps to dock to each other. And again, this has to do with developing algorithms to guide the vehicles and to control them. We do a lot of testing, indoors and outdoors, and a lot of this work, a lot of the testing work is done as part of NCFRN, which is the NSERC Canadian Field Robotics Network. So every year we go out and we test in the field, in other environments. We've done some testing in the Canadian Space Agency. And of course, we do a lot of testing in my lab. This is a collision experiment that, where we actually fly the vehicle on purpose into the wall, and developing controllers to recover from a collision like this is the next step. So the last thing that I just want to mention is one of the things that's happening at the Center for Intelligent Machines, which I'm a member of, there is an initiative to put together a proposal to CFI, Canada Foundation for Innovation, to build a new lab in the engineering complex. And as part of this proposal, we hope to take up the engineering complex courtyard and convert it into the outdoor lab where we could experiment with the vehicles. So I'll conclude here. I don't think I have time for questions. No? No. All right, but I'll be happy to talk to anybody after.